Hello, this is the section 9.5 lesson on the topic of strip diagrams in algebra. In this short lesson, we're going to look at a couple of word problems that we'll solve by using strip diagrams and then a little bit of algebra based on our strip diagrams. So the basic procedures that we're going to follow here in these problems is to first of all draw a strip diagram. Now we've drawn strip diagrams earlier on in the semester for very simple problems. These strip diagrams are going to be a little bit more involved, but not terribly complex. And so a strip diagram is going to be just a simple picture that helps illustrate the different numbers, the different unknowns, the different parts of the problem. And then the second step is we're going to set up some algebra and then do some algebraic manipulation to solve the problem. Now, one question you might ask yourselves is, well, why do we need the first step? Why do we need to draw a strip diagram? Why don't we just skip to the algebra and be done with it? Well, there's at least a couple of reasons why we might want to draw strip diagrams. Number one, they help organize the information in the problem. And then second, they help explain why the algebra is set up the way it is. Sometimes when we do algebra, it's not real clear how to set up the original equation directly from the problem. But if we draw an intermediate strip diagram to help in that process, it'll help to explain to ourselves and to our students and to others why we do the algebra the way that we do. So let's look at our first problem. The Browns are buying a TV that costs $1,300. After they make 4 equal payments, they still owe $400 on the TV. How much was each payment? And so first we'll solve it using just a strip diagram, and then over here we'll use that strip diagrams to help set up some algebra. And so we're going to start off with just this long bar that we call a strip, and we're going to label that long bar $1,300. So there's the total cost of the TV. And then we're going to cut off one chunk at the end, or one piece, or one part, whatever you want to call it, and label that $400. So that's the $400 that they still owe. And then the remaining bit of the strip is what we've already paid. So we're going to break that part up into 4 equal pieces. Now notice that these pieces here are not necessarily the same size as this piece here. It's possible that they could be the same size. Right now we don't know. But all that we do know for sure is that each one of these pieces is the same size. And then we're going to label that with a question mark to illustrate we don't know how big that piece is. And our ultimate goal is to figure out how big that piece is. And so from our picture we see that 4 parts, these 4 pieces here, correspond to the total length of the strip minus the $400 that we already paid, which is $900. And then if we divide both sides of this by 4, we get that one part is equal to, or corresponds to, 900 divided by 4. We do that arithmetic and get 225. And so one part there, or one piece, or one payment, is $225. So now let's use that same strip diagram to set up some algebra. So we're going to label things basically the same, except that we're going to put an X in each one of these boxes to represent our unknown. So we're not going to call our unknown just question mark. We're going to call our unknown X, and we put a $sign in front of that to indicate that X is really a dollar amount. And then down here we clearly define that variable. X is the number of dollars in one payment. We're very precise in our definition. And so now from our picture we see that we've got 4 x's there, so that's 4x plus the 400 that we still owe equals the $1,300 total price of the TV. And so now we've got our algebraic equation. Now we just need to perform some algebra there to solve that for x. We move the 400 over and then divide by 4, and we get that x is equal to 225. So each payment was $225. So we get the same answer either way with using just strip diagrams or with algebra. And notice that our arithmetic down here was basically the same as arithmetic over here. We just got to that arithmetic in a little bit different way. But also notice how this strip diagram helps explain why this equation is the way it is, and where that equation come from. We didn't just pull that out of the air. We reasoned through it, and our picture helps explain our reasoning. Let's look at another problem. It's a little Harry Potter problem. Altogether, Ron and Hermione have 70 ragworts. Hermione has 7 more ragworts than Ron. How many ragworts do they have? Do they each have? And so we'll draw a strip diagram first. So we've got kind of 2 parts to our strip diagram here. We've got Ron's and Hermione's. And so Ron there has a strip. We don't know how long that strip is. That's what we want to figure out. And then Hermione has 6 more ragworts. So we're going to draw the same size strip and then add another piece there that we'll label 6. And then we know altogether they've got 70. So we put this little arc there to indicate that altogether we've got 70 ragworts. And so from the picture we see that we've got kind of 2 parts there, 2 pieces that we don't know how big they are. So 2 parts corresponds to the 70 total minus these 6 here that Hermione had extra. So that's 64. So then if we divide both sides by 2, we get that 1 part corresponds to 32. And so then Ron has 32 ragworts, and Hermione has the 32 there plus the 6, which is 38. Now let's use that strip diagram to set up an algebraic equation. Same strip diagram, but now we're going to label each one of those pieces with the letter R. And that indicates that R is the number of ragworts that Ron has. So again, notice that we've clearly labeled things, we've clearly identified what our variable is. That's a very important part of drawing a good strip diagram. And now from our diagram we see that we've got 2 pieces of length R plus 6 pieces equals 70. So that's how we come up with this equation. And then we just do some algebra. Subtract 6, divide by 2, and we get that R is equal to 32. So same answer. And again, notice that the arithmetic is basically the same as what we did with strip diagrams. We just had a little bit different way of getting to that arithmetic. So a couple important points that I want to stress here when you're drawing strip diagrams. Number 1, keep the diagram simple. These shouldn't be very complicated. They should be something that anybody, our classmates, our colleagues, our students could look at and clearly understand what it is we're trying to say. And the second point is to clearly label everything. If we know the length of something, then label that with a number. If we don't know the length of something, then label that with a question mark or a variable.